Hello, in this tutorial we will derive the basic formulas for Laplace transforms. So what is a Laplace transform? So we define Laplace transform by this uh, equation. So f of s is equal to Laplace of f is equal to 0 to infinity e power minus st times function which is in terms of t dt. Okay, so here this capital F of s is the Laplace transform of a function f of t. Okay, if we have a function in terms of t or any other variable, we can transform it into a function in terms of s. Okay, and that function we will call as Laplace. So Laplace, we represent this symbol L, kind of L. Okay, and basically it is an integral from values of 0 to infinity of exponential function minus st times ft. So if you want to find the Laplace transform of any function, you will multiply it by minus e power minus st, and then you will take an integral from 0 to infinity. Okay, so this is the basic definition. Okay, so using this definition, we will convert various functions into their Laplace transforms. So we will start from a function which is equal to 1. Okay, just a function which is equal to 1, or you can even say that a function which is a constant a. Okay, a is a constant. Okay, a can be any constant. Okay, so this Laplace transform, its Laplace transform will be in terms of s, or we can also say that the Laplace transform of a, okay, will be equal to 0 to infinity e power minus st times a times dt. Okay, in this case this function is very simple, a, and then we can see that it will be if we integrate from e to power minus st, so it will be e power minus st for the integration divided by minus s, and its integration limits are infinity to 0. So now if we will apply these limits, so it will be minus a over s. Okay, minus a over s, and then if we apply a limit on this for infinity over here, it will be e power minus infinity, that is 0, and then e power 0 minus e power 0, it will be 1. So we will get a function a over s. So we can say that Laplace transform of a is equal to a over s. Or in this way, if we take a is equal to 1, if we take a is equal to 1, so the Laplace transform of 1 will be 1 over s. So this is one of the earliest formula which you can derive for the Laplace transform. So let's move forward and then try another Laplace transform. So for example, instead of a, we have a function e power at. Okay, so we want to find its Laplace transform. So the Laplace of e power at, okay, will be equal to limit from 0 to infinity, and for every Laplace transform, by definition, we can multiply it. We have to multiply it by e power minus st, because Laplace is a function which is in terms of s. Okay, this is by convention we use s. So although we can use any other thing as well, so by convention we use s. So it will be e power a t dt. So we can integrate it. Okay, so let's little bit simplify it. So it will be minus s minus a times t dt. Okay, we can write it like this: minus s times minus a times dt. So minus minus plus at, so it is fine. and its integral will be, so its integral will be this e power minus s minus a, okay, and divided by minus s minus a, and its integration limits will be infinity and 0. Okay. Okay, so now how this integral, how these limits come out. So we have this minus s minus a here, and what it will be, so it will be sorry, here t will be here. Okay, so if we take infinity over here, so it will be minus, so s minus a, and then it will be minus infinity. But here we have to make one assumption, is that we will say that s is greater than 0, okay, and also s is greater than a, so that s minus a will always be a positive number. Okay, if it will be a positive number, then that will be a negative number, so it will be minus infinity. Okay, so s is greater than a and s is greater than 0. Okay, so we have these two things should hold. So at e power minus infinity is 0, and then e power 0 is 1, so it will be 1. So now we can see that this term in this brackets is minus, so it's minus minus cancel out, so it will be 1 over s minus a. So therefore we found another formula, that e power at is equal to 1 over s minus a. Okay, so here we can see one okay, although we will prove it later on, here we can have one hint, is that which is called as the S shifting theorem. So for example, earlier we found that the Laplace transform of 1 was 1 over s. Okay, so if we can write L e power at as Laplace transform times 1 times 1 as like this, and if we take the Laplace transform of 1 as 1 over s, and then we are multiplying it by at, so it means with the multiplication of by at of 1, we can see that we already know that its Laplace transform is s minus a. So it means that maybe it is true that if we multiply any function, not just one, then its Laplace transform we can get by just simply subtracting a from s. Okay, although it does not prove for any other function, but this gives us a hint. So this type of thing is called as the S shifting theorem of Laplace transform. Now, okay, we will prove this S shifting theorem a little bit. We will see about this S shifting theorem a little bit later on. Okay, so with these things in mind, we can also find the Laplace transform of hyperbolic function cosine cosh at. So suppose that Laplace transform of cosh at we want to find. Okay, so how we can find? So we know that, since we know that cosh at is actually what is cosh at? Cosh at is e power at plus e power minus at divided by 2. Okay, and we can very easily see that the Laplace transforms follows the subtraction and addition rule, so which means that we can take this 1 by 2 out. Okay, and then we can represent it like this. It is a Laplace transform of e power at, and plus it will be a Laplace transform of e power minus at. So Laplace transforms, I'm not proving it over here, it's very easy, and then you can see from the textbook that Laplace transforms follows the rules of addition and subtraction. So we can apply the Laplace transform of this, apply the Laplace transform of e power minus at. So we just have proved that Laplace transform of e power at is s minus a. So it is 1 by 2 over 1 minus s minus a, and it is it should be by the by the similarity of this, a will be just replaced by minus a, so it should be s plus a. And then if you simplify it, then it will be 1 over 2 s minus s square minus a square, and then it will be s plus a, and then it will be plus s minus a. So it will be 1 over 2. A will cancel with a, so it will be 2s over s square minus a square. So we will finally found out that the Laplace transform of cosh hyperbolic at will be equal to s over s square minus a square. Okay, so by the same principle we can find out that the Laplace transform of sin at, sine hyperbolic at, will be equal to Laplace transform of e power at minus e power minus at divided by 2, and just do the similar calculations. You will find out that it will be a over s square minus a square by the similar calculations, a over s square minus a square. Okay, so that was easy. Okay, so yeah, so you can see that we have found out the Laplace transforms of the hyperbolic function cosh and sine, sin, etc., but we have not found the Laplace transform of cosine or sine function. So that we are going to do now. So Laplace transform of cosine function. Okay, so in this case we take like cosine of omega t. Okay, and similarly we can do it for sine of omega t as well. So the Laplace transform of cosine of omega t will be by definition. So we have to go by definition from here. So 0 to infinity e power minus st, and it will be cosine omega t dt. So for this now we have to go by the integration by parts, and one of the shortcut method for the integration by part is the DI method. Okay, I have explained it some time ago. So DI method, I take this for integration, I take this function e power minus st, and for derivation I will take this function cosine of omega t. So I will take the derivative of this. It will be minus omega sine omega t, and then it will be minus e power minus st over minus s, and then I will do it one more time. So it will be minus omega square cosine omega t and it will be minus e power minus st over s square. So here it will be minus s, and then minus minus it will become s square plus. Okay, so now this will not continue. I mean, it will never finish, but we have to do one trick, then we can find it. So it will be sign convention plus minus plus. Okay, so now by this approach we can write it like this. It will be cosine of omega t e power minus st over minus s. Okay, so it is minus. Okay, and then this is minus minus plus, so it will be plus. So the next term will be plus omega sine omega t over s square e power minus st. Okay, we will get these two terms. Okay, and so these terms I can put in bracket, and then we need to apply the limits of the integration, and the last term will remain in the integral. Okay, 0 to infinity, and this will be then we can take omega square over s square, omega square over s square outside of the integral, because both omega and s are constants, because the integration is in terms of t. And now it is e power minus st cosine of omega t dt. Okay, so cosine, so now this e power st cosine of omega t dt. Okay, so now this is this. Okay, we will continue this in the next video clip.